Hello and welcome to our Fast Track to Contactless EMV Expertise course. This chapter will introduce the general concepts about contactless payment. Let's start this chapter with a lesson to discuss what contactless payment is. Contactless payment consists in tapping a card or a device simulating a card on a contactless-enabled terminal. Throughout the course, we will focus on the use of a real card. But each brand also has a way to make contactless payments with a mobile device. In the same way, it is also possible to make payments with objects that have been given contactless capabilities, like a watch. There are two operating modes. Those are MagStripe mode and EMV mode. And we will look in details at the difference between the two modes. Many of the concepts and processes from Contact EMV are still valid. That's why we had a chapter that recaps the key points. Unlike Contact EMV, contactless implementation started before a common framework was agreed upon. I remember when I started working with contactless cards in 2007, you could clearly see that Visa and MasterCard had gone their separate ways. Now everything has been retrofitted into the contactless EMV specifications. There are important conceptual differences among the brand's implementation choices. This will explain a lot of what looks like unnecessary complexity, especially with all the different kernels that we will talk about. Contactless EMV aims at unifying the user's payment experience. We will see that there are guidelines about messages, light, and audio usage, everything to keep a similar experience around the globe. I'm sure that you've already seen how to pay with contactless in a store, for example. The concept is that the cardholder waves or taps their cards on the payment terminal when they are prompted to do so. There's an interaction between the terminal and the card, and then the transaction is approved and the customer may leave with the goods. If we were to look closely at a contactless card, we would see that there is an antenna inside. A bit like your mobile phone has an antenna that runs around the screen for Wi-Fi, a contactless card has a wire running around its edges to act as an antenna. With some cards, especially test cards, you can actually see it by transparency if you look at it with a bright light in the background. It is also why, if you bend the card, usually by leaving it in your pocket, the contact chip will still work, but it will not respond to contactless anymore, simply because the antenna is broken. The way contactless works is by having the payment terminal act as a transmitter, and the chip card act as a receiver. The terminal will generate a magnetic field that the chip card will catch thanks to its antenna. The field is converted into electricity and serves to power up the chip card at the same time as it is used to transmit information. Contactless payment works most reliably when the card is presented between 1 mm and 10 cm from the antenna of the terminal. Presenting the card closer to the terminal's antenna means that the card will get a better signal, which means that it will typically work better. The way to verify the cardholder may differ slightly from a contact transaction. Because offline PIN verification requires exchange of data between the terminal and the card, it is not supported for contactless. It would be just too awkward to ask a cardholder to hold the card in the right position at the same time as entering their PIN on the PIN pad. Because if they move the card just slightly, but out of reach, then the transaction would be cancelled, and that would be just a bad user experience. So offline PIN is altogether not supported for contactless. What is supported are methods that can be processed after the terminal is done interacting with the card. Those include online PIN. We're still asking that the cardholder enter the PIN on the PIN pad, but that's after removing the card. With online PIN, the PIN code is sent to the issuer for verification along with the authorization message. If you want to know more about online PIN management, be sure to have a look at the free trial of our course on ISO 8583 and transaction processing. There is a free lesson on this topic. Another cardholder verification method, this one only supported for contactless, is confirmation code verified. This one involves the use of a consumer device, like a mobile phone, and it quite vaguely refers to the fact that the consumer has positively completed a CVM on their consumer device. This may be as a result of a single presentment with the confirmation code pre-entered by the cardholder, or it may be the result of two presentments with a restart and the confirmation code being entered by the cardholder when prompted by the kernel. Essentially, it's for the brand and the issuer to decide how to implement this. Another CVM that is still valid for contactless is signature verification. And finally, no CVM. Let's look at the whole POS system. There is a broad range of possible architectures, but EMV has designed a descriptive model that looks something like this. Conceptually, it is along the lines of an intelligent reader device, which is considered to be the most widespread architecture, but it is not intended to be prescriptive. The right-hand element represents a reader which communicates with the contactless card and processes the contactless application. It therefore includes the functionality of entry point and the contactless kernels. It will also normally contain the user interface of cardholder-facing display, visual status indicators such as lights or LEDs, and beeper. The left-hand element maps more closely to an EMV contact terminal. It includes the merchant input and display, the online communication interface, plus any contact or MaxWrap interfaces. Functions such as signature CVM or online PIN CVM are expected to be acquired the same way as for an EMV contact terminal. As we said at the beginning of this lesson, the notion of kernel is quite central when it comes to contactless EMV. It is described as follows. A kernel is software in the POS system that processes certain contactless transactions. Entry point selects a kernel based on the characteristics of the transaction, the application supported by both the card and the reader, and the priority that may be assigned to each application. You will see that there is a kernel for each card brand, which basically contains the different processing steps that were retrofitted from the way that each brand had historically implemented contactless. Let's look at a high-level architecture diagram that will put the kernels in context. A contactless transaction starts with the activation of the contactless module, followed by the card being presented to it. The reader then looks at what brands are available on the card, and goes through a process that we will look at in details later, called combination selection. Essentially, it maps the brands available on the card with the kernels available in the reader. Then comes the actual brand processing. If the card is MasterCard, then the transaction is processed with kernel 2. If the card is Visa, then the transaction is processed with kernel 3. If the card is American Express, then the transaction is processed with kernel 4. If the card is JCB, then the transaction is processed with kernel 5. If the card is Discover or Diners Club, then the transaction is processed with kernel 6. And if the card is UnionPay, then the transaction is processed with kernel 7. Once the kernel processing is complete, the reader goes into a process called outcome processing, which we will discuss in the next slide. EMV mandates that this overall process, from activation to outcome processing, takes less than half a second. The split is that the card may take up to 400 milliseconds for its internal processes and communication, and the terminal may use the remaining 100 milliseconds. Let's look at outcomes. EMV defines an outcome as the primary instruction from the kernel or entry point on how processing should be continued. The parameters allow the kernel to indicate choices, such as messages to be displayed and whether the kernel wishes to be restarted after an online authorization. Essentially, the kernels allow each brand to process a contactless transaction their own way, and the outcome processing step is when they all come back together. So you see that contactless EMV is actually a big wrapper for contactless transactions. The first possible outcome is select next. The kernel has determined that the selected combination is unsuitable, and the next combination, if any, should be tried. The next possible outcome is try again. The kernel wishes that a card be presented again. This may be a result of an error, such as tearing, that could resolve if the transaction is attempted again. It is one way a kernel may handle a mobile device that requires a confirmation code to be entered. The next possible outcome is approved. The kernel is satisfied that the transaction is acceptable with the selected contactless card application and wants the transaction to be approved. This is the expected outcome for a successful offline transaction. This might also occur following reactivation of a kernel after an online response. The next one is declined. The kernel has found that the transaction is not acceptable with the selected contactless card application and wants the transaction to be declined. This might also occur following reactivation of a kernel after an online response. The next one is online request. The terminal requires an online authorization to determine the approved or declined status. The next one is try another interface. Either the kernel is unable to complete the transaction with the selected contactless card application, but knows from the configuration data that another interface, for example, Contact or MacStripe, is available. The kernel could indicate a preference for an alternate interface. Or the reader was unable to identify a contactless card application that could complete the transaction, and returns control to the POS system, which might attempt a different interface. And the last one is end application, which can mean any of the following. The kernel has completed processing and requires no further action. Or the kernel wished to restart after the card has been removed. It is one way a kernel may handle a mobile device that requires a confirmation code to be entered. Or the kernel experienced an application error, such as missing data, that will not resolve if the transaction is attempted again with the same selected contactless card application. Or the reader was unable to identify a contactless card application that could complete the transaction with the current card, and wants the POS system to direct the cardholder to present another card. So this is the complete high-level picture of how contactless payment works. This concludes the first lesson in this chapter. Thank you for watching it.